Hello and welcome to Pascal's triangle. I'm going to show you exactly what Pascal's triangle is, and then I'm going to show you a way to develop the numbers in it. Let me start off by showing you what it actually looks like. Starts like this. You have a 1, then you have another 1 and a 1, and in the next row here we have a 1 and a 1 on the outside. Now to get this number in the middle, you add the two numbers in the previous row that are kind of kitty corner to it. So this would be a 2. Then I carry on to the next row with outer 1s. Now in here there'd be a 1 and a 2, so they add up to a 3. Same thing over here. Now we can go another row here, 1, then this would be a 4. 3 and 3 makes 6, 3 and 1 makes 4, and then the outer 1, and this can go on forever. Okay, so here we are working out all these different numbers, and you might say, hey, that's pretty cool, but I'd like to know if there's a point to this nice little triangle. This, of course, goes on and on. There is a point. Before I rush into that, let me just define this is called row 1. And of course, this would be row 2, and so on. Okay, row 3, etc. Now, here's where it gets tough. It's easy enough with the first few rows. You can just sketch them out. But what if somebody comes along? I'm going to clear this off here. And somebody says, suppose we go down to row 12. Yeah, let's go down to row 12. And I was wondering, what is the fourth term from the left? So the fourth term in from the left. Okay. Now here's the thing. You really don't want to be drawing Pascal's triangle and working your way down to row 12, because that's a lot to sketch out. And albeit you could probably do it pretty fast. But what if this was the 42nd row? Okay, so I mean, we can make the questions virtually impossible to do. Well, a funny thing happens. I'm going to redraw Pascal's triangle, but instead of the first row having a 1, I'm going to put in its place 0, choose 0. Now, if you take your calculator and you work that out, you get a 1. Okay. Then in the next one, I'm going to go with 1, choose 0, and 1, choose 1. Now, if you work these numbers out, you get a 1 and a 1. Okay. Now, that was 0, then 1. So the next one would be a 2, choose 0, 2, choose 1, and 2, choose 2. And if you worked out these numbers, you would get a 1, a 2, and a 1. Now, I think you kind of see why we're doing this. What it does for us is it becomes a way to figure out things like the 12th row and the 4th term in. You just got to count carefully. I think what makes this a little bit tricky is that you see how the first row is 0, and the second row is a 1, and the third row is a 2. These, unfortunately, are always 1 less than the row we're talking about. So if we are talking about row 12, we're actually going to be looking at 11, choose. And they always start with zeros. It's always 11, choose 0. Then it would work its way in by increasing the number of things that you're choosing. So 11, choose 1, 11, choose 2. And so that was terms 1, 2, 3. And here's the term we're after, 11, choose 3. That's the fourth term. So now I could take my calculator, or I could take formulas, and I could work out exactly what is 11, choose 3. Turns out it is 165. Okay? So the idea behind this pattern here of using the choose, the combination stuff, is it's a way to bypass actually constructing the entire triangle. All right, that's probably a good place as any to stop. As for the point of Pascal's triangle, well, more on that later. So we're going to sign off.